I said that was the final example, but let's look at a sort of a real-world application of function composition, and then we'll be done with this idea of composition. Let's suppose we have an oil spill in the ocean, and as the oil is spilled, it's in the shape of a circle with a radius of 10 feet. It's just an assumption. So the circle has a radius of 10 feet to start out with, but as you know, oil starts to spread out, and will spread out kind of uniformly, maybe in a circle, and the radius of the spill is increasing at 2/3 of a foot per minute. So the radius of the spill is increasing at a rate of 2/3 foot per minute. And what the environmental biologist would like to know is what is the area of the spill as a function of time. Not feet, but as a function of time. So let's investigate that problem. Now this radius is increasing at 2/3 of a foot every minute. So the area of the spill is getting bigger and bigger. We can model the radius as a function of time in the following way. We can say the radius starts off at 10 feet, so we have 10 feet, and then every minute thereafter it increases 2/3 of a foot. So we can say 2/3 t, where t is going to be in minutes. So the radius can be thought of as a function of time. We can say 2/3 t plus 10. Then we ask ourselves the question, what is the area of the spill at any time? Of course, the area is the area of the circle. So we got to know, what is the area of the circle? Well, the area of the circle is pi times the radius squared. But the radius itself is a function of time. So we can think of this as the area is a function of radius, but radius is a function of time. And so we can combine both the radius and the area function into one function so that we get area as a function of time. So we say area evaluated at r, which is pi r squared. We can think of that as area evaluated at r, which is evaluated at t. And so that's going to be pi times r of t squared. R doesn't stay constant. R is given by this function, 2/3 t plus 10. So we have 2/3 t plus 10 quantity squared. And so there we get an area, which is a function of time alone, and not the radius. Now we can represent this A of RT as a composition of A, little circle, R, evaluated at t. So for example, at t is equal to, say, 30 minutes. 30 minutes after the oil has spilled, we can use this as a model to figure out what's the area of the spill after 30 minutes. Well, we evaluate A of R of 30 minutes, and that's going to be pi times 2/3 times 30 plus 10 squared. And we can simplify that. 2 times 10 is 20, plus 10 is 30. 30 squared is 900, so this is going to be 900 pi, and the answer is square feet. So this concludes our lesson on function.